Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. Today, I'm going to cover obtaining an equation of a trig function given its graph. And we're going to use the general equation. Well, we're going to actually find this general equation. F of x is equal to a sine of bx plus c, or if it's a cosine function, a cosine of the quantity bx plus c. And we use these three properties of our trig function to be able to find really the coefficients of a, b, and c. So right now I've given you a sine function. We know we can probably call it a cosine function too if you want to start it here instead. But let's just say this is a sine function because it starts at the x-axis. So its amplitude is considered really the distance from the center of the graph up to the peak of its wave. Or another way of thinking about that is the amplitude is going to be half the distance between its minimum and maximum value. So its amplitude is going to be considered this distance right here, because this will also be its amplitude. So a lot of times we say half the distance between its min and max, but people can also visually see that if this is the dotted line, then it's that cuts this thing in half from top to bottom. We can see that its amplitude is this height here, or its amplitude is this height right here. So, if this is, say, 3 here, then I'd say that its amplitude is 3. And, if it's symmetric over this x-axis, then clearly, down here is going to be -3 as well. Its period, which is how long it takes for this function to really repeat itself, through one cycle. All I've done is I said I've drawn it one cycle, but one cycle really would be from this point to this point, because I know what's going to happen here is this thing is going to repeat itself again this way. It's also going to repeat itself again this way. So one cycle being, this distance right here. So that being its period. So this is going to be the period of the function, how long it takes to repeat itself. And that will help us find that coefficient b. Now the reason why it's 2 pi over b is because the normal period of, say, the sine function or the cosine function is 2 pi, because we know when we look at our unit circle, if this is 0, it's going to repeat itself as it goes around, which is also equal to 2 pi and so on. So, they're periodic because of their evaluations are connected to the unit circle. And then its phase shift is how far this thing came off of this vertical y-axis, or their angles. So right now I can see that this thing is, the sine function usually starts here at angle 0, because at 0 the sine is equal to 0. But now it's been pulled off of that a little bit, so its phase shift is going to be this distance right here. I'll just say P of S for phase shift is going to be this little distance right here. Now we say absolute value of these things because I could have pulled this graph this way instead, and then its phase shift would still be considered that distance. Now if it's if it moves this way, your c is actually going to be a negative number, because that means shifted to the right, and if it's this way, it's going to be a positive number. Just like what happens when you're graphing like quadratics. The quantity x minus 3 squared is shifted this way 3 units. All right, so let's put this to practice. So example says determine the function y equals a sine of bx plus c for the graph below. And in this case, what I've done is I've labeled these the x-axis and the y-axis, or the angle axis and the output axis, and I want to be able to find these coefficients a, b, and c for this particular function. All right, so in order to do this, let's just go after these pieces here, and I like the low-hanging fruit, which is the amplitude. So I know that the absolute value of a is going to be equal to the amplitude of this particular function, and we know that amplitude is going to be this distance that goes from the center of this graph to the top, or it's going to be half the distance from the max to the min, and so I know that the max is equal to 2, and then the minimum is going to be equal to -2. So really what we're doing is we have to take, half of this distance, so the distance being from here to here, so the top, subtracting this bottom, so 2 minus a -2 is going to give us a total distance of 4 here, and I know it's going to be half of that, so its amplitude is going to be, this is max minus min divided by 2, which is equal to 2. Now, with, your more simple examples, this isn't really necessary, but if I shift this thing up and down, then that tends to be this tends to be more useful. So when I do a more complicated example, we'll see why I was doing that. So I know that the amplitude of this thing is going to be, this distance from here, which is going to be equal to 2. Now, what that means is that A could be equal to 2, or A could be equal to +2, or -2. And since the sine function, if we practice graphing, it goes up first and then down second, we know that this is actually going to be equal to +2 as opposed to -2. If this thing was upside down, if it looked like this instead, then we know that we'd be talking about -2 instead of +2. That's why we say the absolute value, because it could be a reflection over that horizontal axis. Now, for our period, we know that the absolute value of 2 pi over b is going to be equal to the period, and in this case, absolute value being somewhat redundant because b tends to be positive more often than not in your examples in your book. So the absolute value of 2 pi over b, or just 2 pi over b, is going to be equal to its period. Well, its period is going to be, how long it takes to repeat itself. So you can see that the period goes from here to here. This is our period. So it needs to be equal to this distance. So very similar, if I wanted to find this distance, I had to do, your larger number minus your smaller number. So very similar, I have to take your larger angle. So this is going to be our 3 pi over 2, and I'm going to have to subtract off pi over 6. So 3 pi over 2 minus pi over 6. And that's going to be that, horizontal distance here. So getting common denominators, let's say top and bottom by 3, so 9 pi over 6 minus 1 pi over 6 is going to be equal to 8 pi over 6. Which is going to be equal to, I guess I can simplify this to 4 pi over 3. So if I have 2 pi over b is equal to 4 pi over 3, my goal is to really solve that thing for b. So if I can multiply both sides by b, multiply both sides by 3, it's going to clear that denominator. So this is going to be equal to 6 pi is equal to 4 pi times b. And then finally divided by 4 pi, so 6 pi divided by 4 pi is going to be equal to b. So you can see those pi's will cancel, and then 6 divided by 4 is going to be equal to 3 over 2. Now our last goal is to find our phase shift, and what we know is that phase shift ends up being the distance. This is been pulled off of your original input, or original input, which would be 0. So your phase shift being this distance here. So I know that that phase shift is going to be equal to pi over 6. So we're going to have c over b is equal to pi over 6. Now, when I find this c value, because it's really the absolute value of this thing, very similar to this as well, what I know is it's been shifted this way, so I know that that c value is actually going to be a negative value. So we can just leave the absolute value of c. I can already tell that b is positive, so this is going to be the absolute value of c divided by that 3 over 2 is going to be equal to pi over 6. Another what I'm trying to say is you can kind of ignore the fact that we're using the absolute value of c, and then say, if it's shifted this way, c will be negative. If it's shifted this way, c will be positive. So it's up to you on how you want to formalize your notation. So multiplying both sides by 3 halves, so the absolute value of c is going to be equal to 3 halves times pi over 6. And let's see, 3 goes into 6 twice, so this is going to be equal to pi over 4, but we know that negative pi over 4 because of our shift is that way. Okay, finally we can write the solution to our equation, and I'll do it right here because I have the room. So then I know that f of x, or we can say y, is going to be equal to a, which is 2, sine, our b is this coefficient, which is 3/2, times x, minus our pi over 4 because it's been shifted to the right. So your phase shift is nothing more than your horizontal shift for your trig functions. All right, so let's say one more. Let's go after maybe a cosine function. Maybe I'll make it upside down and I'll pull it up and down as well, because we also know that these functions can be shifted up and down. So sometimes we might even have a d here, and that's going to take care of our phase shifts are left and rights, but we can also have a vertical shift as well, up and down. So let's do one last one. All right, so our last question is determine the function y equals a cosine of bx plus c, and then plus a d, because I also shift this thing up and down. And again, we're going to kind of go after the amplitude, and then we'll go after the period, we'll go after phase shift, and we'll talk about the up and down last. It's really your choice. So these two are really kind of connected to each other because you have to find b before you go after your phase shift. So the absolute value of a is going to be equal to its amplitude, and the amplitude in this case is going to be half the distance from its min to its max. I was trying to avoid to write these things in here, but I'm going to now. So 1, -1, -2, -3, -4, -5. I'm just kind of out of room here. So then I know that the amplitude in this case is going to be half the distance from its max to its min. So 1 minus this minus 5, all divided by 2, so that I have 6 divided by 2, which is equal to 3. And we can kind of see that there's like the center point right here that runs through that curve, and that distance right there is 3. So I'm feeling pretty confident about this answer. Now, the absolute value is equal to 3, so actually a is equal to positive 3 or negative 3. But normally we know that our cosine function looks like this, right? And this is, been a reflection over that horizontal axis. So actually we can see that a is going to be equal to negative 3 in this case. It's upside down. All right, now our period, so 2 pi over b, is going to be equal to our phase shift, is equal to our period, which happens to be how long it takes to repeat itself. So the period being from here to here. We can see that it repeats itself over this interval. So let's call this a period. And we know in order to find that, I'm going to have to subtract these things. So this is going to be equal to 5 pi over 3 minus, is that right? 10 pi over 8. This should be 5 pi over 4. Boop. Let's try that again. So 5 pi over 4 and then minus our negative pi over 4. So what we're going to get is 6 pi over 4 is going to be equal to 2 pi over b, and I guess this thing simplifies to 6 pi over 2, so 3 pi over 2. So multiplying both sides by 2, so 4 pi is equal to 3 pi times b. So dividing both sides by 3 pi, I can see that 4 over 3 is going to be equal to our b. All right, now going after our phase shift. So the absolute value of c over b is going to be equal to our phase shifts, which is going to be the distance that this thing came off of, this axis here. So remember that it usually starts here. We can see it usually starts at that point right there, but now it's been shifted to this point here. So our phase shift being, this distance here, that's going to be our phase shift. So when I look at this phase shift right here, that horizontal distance, I can tell that that is going to be equal to pi over 4. I'm just talking about the distance. Now the reason why it's pi over 4 is because, let's actually talk about that, because what I had before is I had, the phase shift being a point over here, but that point minus 0 would be itself. So the reason why this is pi over 4 is because this distance here is going to be that big point, which is 0, minus that minus pi over 4. the distance from this dot to this dot. So that's why this is equal to pi over 4. Now the absolute value of c over b, which is going to be equal to 4 pi over 3, is equal to pi over 4. So absolute value of c is going to be equal to 4 pi over 3 times pi over 4. Just multiply both sides by the denominator. So this is going to be equal to pi over 3, but now since it's been shifted this way, that we know c is actually going to be positive pi over 3. And last, when we talk about that d, remember that the normal midpoint of this function sits right at the horizontal, or on the y-axis of 0, and this thing has been shifted. We can see down to here, so I can tell that's been shifted down 2 units, which means my d is going to be equal to -2. So finally, when we have our solution here, we can say our function y is equal to a, which is -3. This is a cosine function. B was 4 over 3 times our x. C is positive this time because it's a shift this way. And it's been pulled down 2 units by a vertical shift of 2. Okay, so that is the graph of that cosine function. So if you like the content, please subscribe.